my name is Jocelyn Holman. I'm an MEGN200 and I'm working on Worksheet 2 right now. So this is my submission for number 2, digital inputs, and the second question under that, where I need to do the digital inputs, double code, and add the additional push buttons to my circuit. So I set up my push buttons, and they each have one wire going back to ground, and they each have a wire going to these pin spots 8 and 9. And then I have my LED set up with the first wire coming from pin spot number 5 and flowing through the resistor back into the ground, which is all right here. So looking at my code, some of the changes I made from like the example code was that I created a new input. I actually renamed the first one to button 1 pin and created a new input called button 0 pin. And button 1 pin is the one that if you press it, the thing will turn on, and button 0 is when you press it, the thing will turn off. So I set those, and these are constant integers, so they don't change. And then had to create a new button state for each of them, so that could be like modified in the if statements. So I renamed the first one and then wrote it a second time. For button 0, I had to create the pin mode for the other one as well, so it is also reading it as an input. So the big change in the input is that I added like another thing that's reading the second button at the start, and then I separated the if-else statement into 2 if statements. So the first one checks if the first one is pressed, and that's what low means. And if it's pressed, it just does like the same thing. It writes to the, or it tells the pin to start sending voltage. And then if it doesn't fit that case, it double checks if button 0 was pressed, and if it is, it'll change in the LED pin, that was number 5, it'll make 5 start sending 5 volts through, and it'll check this every 50 milliseconds, and I didn't change the delay there. So without further ado, this is 1 and this is 2. First one, press it, turns on, chills out. Then when we press the second one, turns off. And yeah, that's what I had so far. And I'll keep cranking to finish up. So thank you. Hello, this is Worksheet 2, Problem 2, digital inputs, and the third one on it, which is the digital input toggle. So let's look at the circuit. As before, the LED is wired with the ground over here, and the power coming from pin number 5, and then the button itself is also connected to ground, and it is connected to pin number 9. So using this setup, alright, so I changed the constants with the pin input, then created a new variable called button tog, which is our toggle variable. There is nothing to add to the setup, and then the majority of my changes were to that final void loop. So this right here reads whether the button pin is pressed or not. So I set my if statement to only, or to double check, or to run when the button itself is pressed. So if the button is pressed, it checks the toggle whether it's 0 or 1. So if it's at 0, it sets it to 1, and then if that's not the case, it has an else if that sets it to 0 if it is at 1. And I originally had 2 if statements, and I was really confused, but what was happening, it was just switching back really quick. So after that was established, I kept very similar if statement to like the original, where if the button itself, or if the button toggle is set to 1, then it will turn on the LED, and then else that means the button toggle is set to 0, and it'll turn the LED off. So, yep, it works. Thank you. Hi, I'm Jocelyn. Worksheet number 2, MEGN200. I am on part 3, the ultrasonic distance sensor, and working on the second one, or I completed the second one, which is the ultrasonic RGB. So, walking you through my code, I start off, and like this was from the example code with sorry. So this is the importing the library and everything, and figure all that out, which I'm pretty sure is kind of black magic, but at that point we have A, which is the distance being read by the ultrasonic sensor. So I defined all these pins, but the blue one isn't used, but I was just kind of setting it all up and realized I didn't need it. Then I'm like setting up the pins as well, red, green, blue, and like I defined them right over here, which slots they're in. So, classic setup stuff. Here I'm defining my variables. So I used 200 and 150 because that gave me the best combination for yellow in like the earlier part of the thingamabob in the worksheet. So I set this to 200 and 150 because when they come together they make a nice shade of yellow. So in the loop, this is the stuff from the example code where it's just reading the distance from the ultrasonic sensor and delaying, it's printing it out into like the monitor, and it's doing like a short delay between each reading. And then based on the readings, which are A, which is the distance, I set up these parameters. So if A is greater than or equal to 16, it has to show green. So, sorry, there we go. It has to show green. So I make sure that red is equal to 0, and then I set green as equal to 150. After that, because everything above 16 is wiped out or not a thing, I can just use an else if statement from A is greater than or equal to 10, or 10 is less than or equal to A. So that's just all the values left, and that one has to show yellow, so I let it write red and green with the values from above. And then lastly, there's red, and that'd just be everything under 10 not equal to, so 9, including 9 and under, and that's there. So demonstrating how this works, I got this journal that I can use. So when I put it right here, the LED is red, so I scoot it back. There we go, now it's yellow. Now it's green. Come on, now it's yellow. Now it's red again. Now it's yellow. Or now it's green. Now it's yellow again. And then let's get it back to red. Now it's red. Thank you. Hi, Jocelyn Holman here again. Filming for the last part of number 4. Okay, worksheet 2, number 4 LCD display, and then the LCD circuit. So let me go to my code. Okay. None of this stuff changed. This was the given top part to us, setup and everything. But here's where I updated the commented code. Excuse me. So we have to do a digital read of the push button pin and assign value to the variable button state. So we learned how to do this at the very first part of the worksheet, so I was able to do that. And you set the cursor to column 0, line 0, first last row, first column, and it kind of walked us through that by putting this here. So using those numbers, I was able to figure that out. And then need to read the ultrasonic distance center. So this is like the function for that. It's kind of like the black magic thing that was given to us through the library. And then need to print it out on the board thing. So this is basically putting like the word distance there, putting a space, then printing the actual value, where a is like right here, what we get from this, and then subtracting it from the datum, which is basically the spot that you kind of mark, you know, where like you press the button. Anyways, I'll go into it later. And then you add the unit centimeters at the very end behind that. And basically the exact same thing, but just moving down a row where it's actually printing the datum value, and there's like the datum saying the word, literally the string datum, then the value itself will be printed, then centimeters. So in the if statement, if button stays low, and low means pressed, LCD clear, it's gonna clear the. I'm sorry my video cut out for a second, my phone ran out of space, I did delete some stuff. But catching back to where we were, button state means that it's low. Sorry, when it says low, it means that the button has been pressed. It clears the entire screen and it says datum equal to A, and that's like the current spot they'll be like comparing it from. And then it delays to slow down the code. I think I mentioned at the beginning, but this is like reading whether the button is being pushed or not. So when we look at the actual monitor, let's see if I can brighten this up a little bit, or if that's as good as it goes. Okay, I guess that's as good as it goes. As like I like move my hand further from, I could grab my notebook again, but you can see that like that value changes. Okay, I'm gonna grab my notebook, see if I can get a better reading. Let's try that. So the datum is set at 115 because I pressed the button. So right now it's at -108 from that point. So I'll press the button right now. Now that I've pressed the button, the datum has been set at 7 centimeters, and that looks like about 7 centimeters. And the like distance can now change as I move my book. There we go. So as I move my book further, the distance changes. So that's what I did. Thank you.